I want to show you how to solve this one. Well, really, we're not trying to solve it. We're trying to prove that the general solution of the homogeneous, thank God, is homogeneous. That gives us a little bit more, it's a little bit easier to solve. But we're not asked to solve this. Actually, we're given the solution, and we're asked to see if this solution is actually valid. And we're going to write it in Matlab. So I'll just bring it over to Matlab and let's do it together. So the first thing that we're going to do, we're going to clear all previous variables. How do you do that? Clear all. Then we're going to write, I'm going to defining some variables, and we have sims t. Then what are we going to do? I'm going to define the coefficient matrix. So again, how do you define a matrix? Well, you have A, you put equal, and then you want to put the square brackets, and you have 0, 6, and 0, semicolon, 1, 0, and 1, semicolon, and 1, 1, 0. And then we put a semicolon at the end because I don't want it to output over here. So the semicolon here tells MATLAB, this is my first row, this is my second row, this is my third row. Then what else do we do? Well, I'm going to define the solution. And now I realize that in my solution, I also have those three constants. So I'll add them here because otherwise MATLAB won't be able to deal with them if it doesn't know what they are. And I'm telling you, they're variables. They're variables, but they're constants. You know what I mean? They are symbols that stand for a value. And now we're going to define that, that solution. So it's C1 multiplied by the vector 6 in the first row, -1 in the second row, and -5 in the third row, and all of that is multiplied by e to the negative t. And then we're going to add C2, so this is probably the second solution, and they were all added together with the superposition principle. And that's going to be multiplied by another vector, which is the vector -3 in the first row, 1 in the second row, 1 in the third row, all multiplied by e to the -2 t. And then we have one more. So we have another vector here. Let me make this a little bit larger, like this. And we have 2 in the first row, 1 in the second row, 1 in the third row, and this is all multiplied by e to the 3 times t. And I don't want it to output. So let's just double check that this is correct. So C1, 6, -1, -5 times e to the -t plus C2 times the vector -3, 1, 1, e to the -2t plus C3. See, I forgot the C3 here, but that's important. So I'll put it in there, and then 2, 1, 1, e to the 3t. Okay, well, now that we have that, we can see if this solution is right. So verifying the validity of the proposed solution. So how are we going to do that? Well, we have the derivative on the left-hand side, so that's going to be the derivative of x. As I said earlier, this will already pick that it's with respect to t because that's the only independent variable that we have over here. If we had more, then we'd have to specify with a comma and the name of the variable. And then we're going to set it equal. Equality is given by 2 equal signs in MATLAB. And then we're going to have a multiplied by our solution here. We're not going to put a semicolon because I want it to output. I press Control Enter, and I see that we have an unrecognized function or variable, C1. Let's see, why is this C1 not recognized? Because I declared it right here, but still it is not recognized. So it looks like, Oh, see, silly me. This is supposed to go over here where I'm declaring the variables. This is to clear all other variables. It has nothing to do with it. So now we should run it again and see what happens. And we get the left-hand side is equal to the right-hand side. It's a little long, so they grouped everything together. But the idea is that each left-hand side is equal to the right-hand side. So this is verified as well. I hope you learned a lot, and I'll see you next time.